Hello, dear aspirants. Myself, your mentor, Aadityaamlan Panda, and I am here to discuss with you the question which we had posted in the community post of Being IITian channel. So here is what the question said. When a ray of light travels from a denser medium to a rarer medium, from a denser to a rarer medium, then what is the range of values of angle of deviation for which there is one angle of incidence for every angle of deviation and there are two angles of incidence for every angle of deviation? Here, the question is a little bit conceptually challenging because the usual approach of using formulas to solve questions of ray optics won't work here. You heard it right. It won't work because you have to use the geometrical approach here. That is, you have to draw diagrams as well as you have to use the graph. Now, in the following slides, I would be drawing diagrams in three phases. And in each of these diagrams, I would be considering that the ray of light is traveling from the denser medium to the rarer medium. So let's get started. Case 1. When the angle of incidence of the ray traveling from the denser medium to the rarer medium is less than the critical angle. Now, for your information, critical angle is the angle of incidence of a ray of light traveling from a denser medium to a rarer medium when the angle of refraction in the rarer medium is 90 degrees. So if angle of incidence is less than angle of critical angle, then in that case, it is merely refraction and the angle of deviation is angle of refraction minus angle of incidence. Now you can simply use Snell's law, that is sine I by sine R is equal to a refractive index of the rarer medium divided by refractive index of the denser medium, which is also equivalent to 1 by mu relative, and you can easily understand what is mu relative if we are considering the rarer medium to be A. Now simplifying it further, sine R taken to this side would be equivalent to mu relative into sine I. Now taking sine inverses either sides would give you R equivalent to sine inverse of mu relative sine I. Now using the same formula, that is angle of deviation is equal to subtracting angle of incidence from angle of refraction, you would get delta is equal to sine inverse of mu relative sine I minus I, and this equation, as you can see, is not a linear relation. Now second case, when the angle of incidence is equivalent to angle of critical angle. Now in this case, the angle of refraction in the rarer medium is equal to 90 degrees or pi by 2 radian. And now again using the same formula, that is delta is equal to R minus I, as it is again reflection in this case also, we can find it out that delta is equal to pi by 2 minus I, and let's consider it as delta 1. Here this angle of refraction is the pi by 2. Now if I increase the critical angle little bit, like angle of incidence is equal to critical angle plus di by an element di, then it will lead to total internal reflection. As you know, if an angle little bit more than the critical angle will lead to total internal reflection. अगर आपने angle of incidence critical angle से ऊपर ले ली तो उस केस में total internal reflection बनती है. Now it will simply divert the formula for angle of deviation into the formula we use to calculate the angle of deviation in case of reflection. Now since here reflection is occurring, then angle of deviation is equal to pi minus 2 into angle of incidence, the formula for reflection, and that would give you here the angle of deviation. Now, since this angle of incidence is little bit more than critical angle by an element di, we can simply take it equivalent to critical angle itself. So angle of deviation is equivalent to pi minus 2ic, which is equal to delta 2. And let's say again, and do remember these two angles, do note them down. The delta 1 is equal to pi by 2 minus ic, and delta 2 is equal to pi minus 2ic, because these two angles would be used in the same graph which we would be considering later. Now taking the third case, if I make the angle of incidence greater than critical angle, then in that case, it is nothing but total internal reflection. And now how are we going to calculate the angle of deviation here? The angle of deviation in any ways will be calculated by the same formula, that is pi minus 2i. And to give you a glimpse of it, this angle is angle of incidence, alternate angles, and this is of course angle of incidence, taking the laws of reflection into consideration. And now this entire angle is pi. So delta is equal to pi minus 2i. And this is no doubt a linear relation. Now, coming back to the graph, what graph did I mention before? Can we plot a graph of angle of deviation against angle of incidence? I have plotted one. Here this delta 1, as I had told you to note it down, would be pi by 2 minus IC. And here this delta 2 is pi minus 2 IC. Delta 1 is the value of angle of deviation when the angle of incidence is equal to critical angle. And delta 2 also, but here it is open. Why? And why is it a concave up and increasing graph? Let's check. For I in the interval of close bracket 0 to close bracket critical angle, if I lies in this interval, then in that case, what would it denote? It would denote refraction. Now here, the angle of deviation is sine inverse of mu relative sine I minus I, as we had calculated it before. This one just by Snell's law, the same one. Now this is an increasing function, and if you want to even prove it, then I have used it here, that the differentiation of delta with respect to I is this value, and this denominator can be simplified into cos r, because mu relative into sine I is nothing but sine r, Snell's law, and 1 minus sine square r is nothing but cos square r, and the root over would give you cos r. So it is cos I by cos r minus 1. And since angle of incidence is less than angle of refraction, as the light ray was traveling from the denser medium to the rarer medium, and but since both the angles are less than 90 degrees, the cos would follow an inverse rule. That is, if angle of incidence is less than angle of refraction, then the cos of angle of incidence would be greater than cos of angle of refraction. You can relate it to trigonometry itself. Now cos I by cos r is greater than 1, dividing either sides by cos r, and cos r is positive. So cos I by cos r minus 1 is greater than 0. D delta by di is no doubt greater than 1, and this is an increasing function, as you saw here. Now, how is it a concave up function? Nothing, you have to take into consideration the double derivative itself. Here I have calculated the double derivative of angle of deviation with respect to angle of incidence, which is equal to this value, where I have taken common sine I by root of 1 minus mu square sine square I, and this one is left inside the bracket. Now here also, if you see, this is 2 and this one is less than 1. 2 divided by something which is less than 1 would increase the value of 2. No doubt this cos will reduce it a bit, but mu relative is again greater than 1. So anyways, this value is greater than 1, and the entire equation here is greater than 0. Thus, it's a concave up function. Now taking into the consideration the second half of the graph, for I in the range of open interval critical angle to close interval pi by 2. Here, the angle of deviation is equal to pi minus 2i, because here reflection was taking into place, that is total internal reflection. And as you can see here, pi minus 2i, the slope is minus 2 and the y-intercept is pi. So since the slope is minus 2, this graph looks like this, and if you extend it further, it will meet the y-axis at pi. And anyways, it was a linear function and the graph is also linear. Now what do we conclude it from here? Like, how is it going to solve our question? Now for that, we need to consider it in terms of angle of deviation. हमें इसको angle of deviation के terms पे सोचनी होगी, और उस हिसाब से ही हम अपने नतीजे पे पहुंच सकते हैं. So this is how we are going to conclude it right here, and the question will be solved. Now taking the first case, suppose the angle of deviation lies between 0 and delta 1. What was delta 1? Did you remember? If you don't remember, I have written it down here. It is very important. It is pi by 2 minus critical angle. This one is a real angle. Remember, this one is a real angle, while this delta 2 is not a real angle. It is a hypothetical angle. Why it is a hypothetical angle? Because during delta 1, when the angle of incidence becomes equal to critical angle, then nothing but refraction takes place. But reflection does not take place. However, to make this graph, we had to consider reflection also at IC, but it is a hypothetical angle, and that is the reason why I have put here open and here closed. It will be equal to this, not this. So in this case, as you can see, it is a many one function. The function is many one as it successfully passes the horizontal line test. The function here successfully passes the horizontal line test, and for each value of angle of deviation, we are having two values of angle of incidences. Now, considering the second case, when delta belongs to open bracket delta 1 and open bracket delta 2. Now, take into consideration the closed brackets and open ones. This one will be 0 to close bracket delta 1. Why? Because 0 it is showing here, and delta 1 do exist in the first case itself. There are two values and delta 1. So it will be closed bracket. Here it will be open bracket because delta 1 does not have one value, it has two values. And delta 2, there is no such angle of incidence for which the angle of deviation is equivalent to delta 2, because there's a hypothetical angle I had told you before. Just we are taking into consideration to draw this graph. Okay. So in this case, the function is nothing but 1, 1, as it does not qualify the horizontal line test, and there is only one I for every delta in this interval. That is, once again, I'm repeating, in the interval of delta 1 to delta 2, there is only one I every delta, as you can see it here. Whereas in the interval of 0 to delta 1, there are two I's for every delta or angle of deviation. So here there is only one I existing for every delta. Now let's revert back to our question. This was the question, right? Only one angle of incidence, every angle of deviation. The graph is forced to be one-on-one in that case. That is, solving the bit 1, we'd be getting that in the interval of open bracket delta 1 to open bracket delta 2, there is only one angle of incidence for every angle of deviation, and that is because of 1-to-1 relation. Or you can also simplify it as pi by 2 minus IC, comma pi minus 2 IC, taking into the phase values of IC itself, that is critical angle. Now solving the second bit, here the graph is forced to be many one because there should be two angles of incidence every angle of deviation, and here it is going to be in the interval close bracket 0 to close bracket delta 1, or close bracket 0 to pi by 2 minus IC. So that was the solution of the question itself. And still, if you have any queries, you can put it in the comment box. And through this video, I hope that I have tried my level best to clear this question as much as possible for you. And so thank you, and keep glowing and keep shining ahead. Thank you.